हेलो मेरे प्यारे बच्चों, वेलकम टू द लेक्चर नंबर 7 of atomic structure. So far in lecture number 4th, 5th and 6th we have discussed the Bohrs model in detail. Now we will take merits and demerits of Bohrs model. By merits we mean the usefulness of Bohrs model, and by demerits we mean the limitations or drawbacks of Bohrs model. So we'll start with the merits of Bohrs model. First merit of Bohrs model is it explained the stability of an atom. Bohr's model explained the stability of an atom by proposing that while revolving an electron around the nucleus in a fixed or particular orbit, it neither loses energy nor it gains energy. These orbits, they were called as the stationary states, and these stationary states, they possess particular or fixed amount of energies. So there is no question of collapse of atoms. Second merit or use of Bohr's model is it explained the origin of emission and absorption spectrum of hydrogen and hydrogen-like species. So this model explained the origin of emission spectrum and absorption spectrum. Emission spectrum was formed by the transition of electron from higher energy levels to the lower energy levels, and absorption spectrum was formed by transition of electron from lower energy levels to the higher energy levels. As far as its details, you have to watch the lecture number 6. Next merit or use of Bohr's model is the values of frequency or wavelength of the spectral lines calculated from Bohr's model were in agreement to that of the experimentally calculated values. So the values calculated from the Bohr's model and the experimentally calculated values, they were matching or they were in agreement with each other. So this proves that the Bohr's calculations were correct. Fourth, the value of R, that is Rydberg's constant, calculated from Bohr's model was in agreement, again same, with that of the experimental value. So the Rydberg's constant, that is the value of the Rydberg's constant calculated from the Bohr's model and from the experiments, they were again matching, they were in agreement or they were in consonance. That means they were almost the same. Again proving that the calculations made for the Rydberg's constant as per the Bohr's model were again correct. So now we'll take the demerits. These were a few of the merits. Now we'll take the drawbacks or demerits or the limitations. So demerits or drawbacks. Drawback number first. The first drawback was simple, that this Bohrs model is applicable only for hydrogen and hydrogen-like species. That is in itself a drawback. That is, it is not applicable for multi-electron atoms or species. Or in other words, we can say it can only explain the spectrum of hydrogen and hydrogen-like species. It cannot account for the spectra of multi-electron atoms or species. So we'll write the first drawback. It does not explain the spectra of multi-electron atoms or species. Second drawback is that when these spectral lines, they were studied under high resolving microscopes, it was observed that these spectral lines, they were further composed of closely spaced lines. That means in our line spectrum, the single line here, say suppose we have a few lines in line spectrum, the single line here, it is further composed of two or more than two fine lines. In other words, we can say these lines in the line spectrum, they possess the fine structure. This fine structure could not be explained by the Bohrs model. Bohrs model इस fine structure को explain नहीं कर पाए. Fine structure of what? Fine structure of a spectral line. तो हम लिखेंगे दूसरा जो इसका drawback था, it does not explain the fine structure of a spectral line. So it does not explain the fine structure of a spectral line, right? Third जो इसका limitation था, third limitation, when the source emitting these spectral lines, it was placed in electric or the magnetic field, these spectral lines, they splitted or dispersed into number of lines. क्या किया गया? मान लीजिए ये source है आपका. This source was placed in electric field or it was placed in magnetic field. ये horseshoe magnet मैंने रखा, जिससे suppose this is north pole, this is south pole, या ये electric field मैंने supply किया, यहाँ से मैंने battery source के साथ connect किया हुआ है, right? So this is negative, this is positive, तो ये connect किया. This is the battery, this is the electric field, this is the magnetic field. अगर हमने electric field या magnetic field supply किया, the spectral lines, जो यहाँ से spectral lines हमें आई, ये prism है, और जो यहाँ से spectral lines हमें आई, यहाँ से spectrum मिला हमें. Say suppose this is the spectrum obtained. जो हमें spectrum मिला, उसकी जो spectral line थी, ये जो spectral line थी, it actually splitted into number of lines. तो बोहर इस चीज को भी एक्सप्लेन नहीं कर पाए. तो हम नेक्स्ट जो बोहर का ड्रॉबैक है वो लिखेंगे. It does not account for the splitting of spectral lines in magnetic or electric field. The splitting of spectral lines in magnetic field is called as the Zeeman effect. ये आप नोट करेंगे point. This is called as the Zeeman effect. Splitting of spectral lines in magnetic field is called as the Zeeman effect, and splitting of these spectral lines in electric field is called as the Stark's effect. This is called as the Stark's effect. दोनों पॉइंट्स आप नोट करेंगे. नेक्स्ट ड्रॉबैक क्या था? नेक्स्ट ड्रॉबैक था एक डेवलपमेंट दैट वाज बाय हीजनबर्ग. हीजनबर्ग ने एक प्रिंसिपल सजेस्ट किया दैट it is impossible to determine the momentum and position of a microscopic particle simultaneously. Simultaneously किसी भी microscopic particle का हम position और momentum नहीं निकाल सकते. लेकिन बोहर्स मॉडल में हमने देखा this is the nucleus, this is your orbit, electron is present in this. हमने radius कैलकुलेट किया, that means हमने position इसकी बता दी और इसकी वेलोसिटी भी कैलकुलेट की. जब हमने वेलोसिटी निकाली तो मोमेंटम तो आ गया, मास इज कांस्टेंट, तो mv आ गया. दैट मींस वी हैव कैलकुलेटेड बोथ वेलोसिटी, दैट मींस मोमेंटम एज वेल एज पोजीशन. तो दिस इज क्लियर वायलेशन ऑफ हीजनबर्ग्स अनसर्टेनिटी प्रिंसिपल. तो हम लिखेंगे बोहर्स मॉडल, फोर्थ बोहर्स मॉडल violates the Heisenberg's uncertainty principle. So it violates the Heisenberg's uncertainty principle of what? Heisenberg's uncertainty principle क्या है? That we cannot calculate, we cannot determine the position and momentum of a subatomic particle simultaneously. तो यहां तो हम कर रहे हैं दोनों. That means the clear violation of Heisenberg's uncertainty principle. Fifth one ये था, there is another development in the physics or we can say chemistry that matter possesses the dual nature, dual character. बोहर्स मॉडल में ड्यूअल कैरेक्टर का कोई मतलब नहीं था. सो बोहर्स मॉडल नेवर टुक दिस ड्यूअल कैरेक्टर ऑफ मैटर एंड रेडिएशंस इनटू कंसिडरेशन. तो हम लिखेंगे द नेक्स्ट ड्रॉबैक दैट इट डज नॉट टेक इनटू कंसिडरेशन the dual nature of matter and radiations as proposed by de Broglie. डी ब्रॉगली ने ये प्रपोज किया था, ड्यूअल नेचर ऑफ मैटर एंड रेडिएशंस. दीज टू कंसेप्ट्स, Heisenberg's uncertainty principle and de Broglie's dual nature concept, we are going to discuss these concepts in detail. नेक्स्ट कुछ लेक्चर्स में हम इन दो कंसेप्ट्स को डिटेल में पढ़ने वाले हैं. तो इन दो कंसेप्ट्स को बोहर कंसिडर नहीं कर रहे थे अपने मॉडल में. सिक्स्थ क्या था? सिक्स्थ ड्रॉबैक वॉज द शेप्स ऑफ मॉलिक्यूल्स. बोहर मॉडल शेप्स ऑफ मॉलिक्यूल्स के बारे में कुछ भी नहीं बोल पाए. हमें पता है शेप्स ऑफ मॉलिक्यूल्स आर ड्यू टू द डायरेक्शनल कैरेक्टरिस्टिक्स ऑफ कोवेलेंट बॉन्ड. एट दिस पॉइंट वी आर गोइंग टू डिस्कस इन द नेक्स्ट चैप्टर, दैट इज ओवर केमिकल बॉन्डिंग. नेक्स्ट चैप्टर हम शुरू करने वाले हैं केमिकल बॉन्डिंग. केमिकल बॉन्डिंग में हम डायरेक्शनल कैरेक्टरिस्टिक्स ऑफ कोवेलेंट बॉन्ड्स, स्ट्रक्चर, शेप्स ऑफ मॉलिक्यूल्स पढ़ने वाले हैं. तो शेप ऑफ मॉलिक्यूल जो है, बोहर्स मॉडल इसके बारे में कुछ भी नहीं बोल पाए. तो हम लिखेंगे नेक्स्ट ड्रॉबैक वाज इट डज नॉट एक्सप्लेन द शेप्स ऑफ मॉलिक्यूल्स. 7 शेप्स ऑफ मॉलिक्यूल्स भी एक्सप्लेन नहीं कर पा रहा. 7 सेवेंथ ड्रॉबैक जो था बोहर्स मॉडल के हिसाब से, दिस एटम इज अ फ्लैट, और बोहर्स मॉडल वाज अ प्लेनेटरी मॉडल, flat model. But nowadays it is very clear that atom is three-dimensional, so it doesn't account for the three-dimensional character of an atom, three-dimensional structure of an atom. So I'm लिखेंगे it does not account for 3D structure of an atom. 3D structure of atom इससे एक्सप्लेन नहीं हो पाया. नेक्स्ट पॉइंट, और ये इंपॉर्टेंट पॉइंट भी था, नेक्स्ट पॉइंट वाज दिस: अकॉर्डिंग टू बोहर, द स्पेक्ट्रम फॉर डिफरेंट आइसोटोप्स ऑफ हाइड्रोजन, इट मस्ट बी द सेम, बट इट वाज फाउंड डिफरेंट. So according to Bohr, the spectrum for different isotopes of hydrogen, it was expected to be same, but it came out to be different. तो हम लिखेंगे according to this model, spectra for isotopes of hydrogen was expected to be same, but it came out to be different. And the isotopes of hydrogen are the protium, deuterium and tritium. In your protium, first you have one proton only. In deuterium you have one proton and the neutron. In tritium you have one proton and two neutrons. So it was expected to be same. लग रहा था कि ये होना चाहिए डिफरेंट आइसोटोप्स ऑफ हाइड्रोजन के लिए सेम, लेकिन जब एक्सपेरिमेंटली हमने देखा तो स्पेक्ट्रम डिफरेंट था. नेक्स्ट इंपॉर्टेंट दिस लिमिटेशन जो बोहर्स मॉडल का था, बोहर्स मॉडल का एक और इंपॉर्टेंट लिमिटेशन था. बोहर्स मॉडल ने हमें कहा था दैट MVR इज इक्वल टू NH/2π, जो हमने लेक्चर नंबर 4 में डिटेल में डिस्कस किया है. That means the angular momentum is quantized and it is equal to the integral multiples of h/2π. This conclusion was after various observations. बोहर ने बहुत सारी ऑब्जर्वेशंस की, उसके बाद ही ये कंक्लूजन आया था that angular momentum must be integral multiple of h/2π. But Bohr could never justify this relation with any of the theoretical explanations. तो बोहर अपनी क्वांटाइजेशन कंडीशन को जस्टिफाई नहीं कर पाए. तो हम लिखेंगे it could not justify the quantization of angular momentum, that is MVR is equal to NH/2π. इस कंडीशन को ये जस्टिफाई नहीं कर पाए. तो दिस इज ऑल अबाउट द ड्रॉबैक्स ऑफ द बोहर्स मॉडल. हमने पढ़ा मेरिट्स ऑफ बोहर्स मॉडल और ड्रॉबैक्स ऑफ बोहर्स मॉडल. ये सारा थ्योरेटिकल पार्ट था, सारा आपको नोट करना पड़ेगा. And this is important so far as your board examinations are concerned. So this is all in this lecture. Thank you.